So we can go ahead and get started. Yep, we're going to be talking about the how and why of flexible React components today. I'm Jen. I'm a senior front-end engineer at a company called ClassPass. Anyone heard of us? Some people, that's good. We're in Toronto, so, you know. If you want to reach out to me on Twitter, or this is where I will post the slides after the talk, go to my Twitter. My handle is girlcode. So I love React. Like, I'm a hardcore, like, diehard fan. It's the first framework that really aligned with how I want to build UI. And I've been working with it for like 4+ years now at this point. So when I was thinking of writing this talk, and I was thinking about, well, what do I want to share about what I've learned over those years about working with React to build flexible components, I knew the technical part of this talk really well, and that's the how. But what I had to force myself to do is articulate the why behind the reasons that I do certain things. I mean, I sort of knew why in the back of my head, but I hadn't actually sat down and written it out before. So to start, let's think about, why do we care if a component is flexible, and what does flexible even mean? In terms of building UI, I think we often equate flexible to mean reusable. So say you're being tasked with building a UI component, and it doesn't really matter what it is at this moment, so I'm just going to represent it with a block. All right, we've got our block. It has 4 sides. It has 4 corners. We are doing really good so far. So when we get a new design with that same UI element, we feel pretty good. These elements are all different colors, but they all share the same structure and functionality. So we get to reuse our previous block element. Except the designer snuck in a change. OK, the functionality of the block did actually change. So the third one there, sometimes it's going to have a tooltip appear. OK, that's fine. It's got a tooltip. We'll add a with tooltip prop to signify that. Things are still OK. OK, a few weeks later, we get a different mock. This time, the block could have a dot in it. OK, let's add a with dot prop. And again later, the same block, different requirement. And we're going to add another prop. So is this component flexible? It's being reused, and we can change what UI it represents with a prop. So this actually seems very flexible. But let's imagine that some time goes by, and you're not working on this component anymore, but your coworkers are. I mean, it's a reusable component after all, and if they need to reuse it, they can just make a little change here and a little change there, and don't rewrite it. We can just add some props. And don't forget, we want to do some A/B tests, and those are just going to be temporary, we think. We're pretty sure. It's the dreaded apropcalypse. So our simple block component is now overrun with props. So what now? Is this component still flexible? I mean, nothing's changed about its reusability. It's still handling multiple UI states based on what props you provide. But I'd argue this isn't a flexible component, and that our idea of reuse can blind us to better, more flexible patterns. So I've dealt with a component like this before, and I would actually guess that most of us have. If you haven't, blessings upon you, may you never have to. So the example I use about the block component is nearly identical to a component that's actually in the ClassPass code base, and it's called the schedule call to action. I'm just going to call it the CTA from now on. If you aren't familiar with ClassPass, we're a membership that allows you to book fitness classes at different studios across your city, which means our UI is composed of various class schedules. And to interact with those class schedules, we have the CTA. All schedules have this. Every single class will have a CTA. It is one of our key components. It's everywhere on the site. And it's a surprisingly complex component. It actually has 5 different states. So if you're viewing schedules as a logged out user, you're going to see a message to prompt you to join. And if you're logged in, you're going to see one of 3 different messages. Either the ability to reserve the class, or you've already reserved the class, so now you would like to cancel the class, or a disabled state that says you can't reserve this, like maybe you've already reserved a class at that exact same time. And then, if you've previously had a membership with us and then you deactivated your account, you're going to see a prompt to reactivate. And it has 3 different behaviors. So it might open a modal, it might link to another page, or it might show a tooltip. And to correctly determine which CTA to show you, this is all the information that I need to know. So is the user logged in, yes or no? What's the state of the user's subscription? Subscribed, unsubscribed, or canceled? And what's the state of the class? Is it available? Is it unavailable? Was it already reserved? When I joined ClassPass, the schedule CTA already existed. I first encountered it when I needed to implement it on a new page. And you can see as I scroll down that it's a fairly complex component for a button. It contains if-else statements, a switch statement, various functional components, so on and so forth. And the history of this component is very similar to the block example. It was created with a really small initial scope. It's just a button that users would click to reserve a class. And from there, more intricacies were laid on top of it. A tooltip, links to other pages, permissions checks for A/B tests, various designs based off of the state. By the time that I needed to use this component, it required 14 props. 14 props! No matter the use case, you needed to pass in 14 props for this component to work. And God help you if you forgot a prop, or worse, you needed to add or remove a type of CTA or behavior. So is this component flexible? The thing is, you can write reusable components that are inflexible. Reusable doesn't equal flexible. So yes, the schedule CTA is reusable, but what happens when it needs to change? Which prop can you safely take away? Which prop is needed for what UI state? These questions are actually really difficult to answer because this component is really difficult to understand. And if you can't understand it and you can't modify it, is it flexible? I would argue that flexibility is about more than reusability. It's about the ability to understand and augment. To me, that's true flexibility. I don't care if your component is used in one place in your application. If I can understand it and change it with ease, that's a flexible component. The opposite, unable to be understood, unable to be modified, those qualities make a component inherently inflexible. But now I need to stop talking about what I mean, and I'm going to show you what I mean. We're going to refactor the schedule CTA, and we're going to start with, hands down, the best starting point for either refactoring or writing a new component. We're going to write down our ideal API. Since React is declarative, we can start from a point of not how we're going to create this component, but what we want it to look like. And this is an important part of building truly flexible components. Often, we focus on the how we'll make a component reusable, when we should be starting with what we want it to look like, and then let that inform how we implement it. For example, the schedule CTA. If we focus on how we're going to render different CTAs all in this one component, it can lead us down the path we've already been, if-else statements, switch statement, and all of that is imperative, not declarative. So let's focus on what we want it to look like. Our ideal API is one prop, the type. That's the entire job of this component. I give it a type, and it gives me back the appropriate CTA. And this is a significant change for this component. And I don't mean in terms of how many props are passed in. We've actually made a fundamental change in the structure of this component because we pulled the logic out of it. So previously, the schedule CTA decided what CTA to show. It relied on those 14 props because it needed all of them to run its internal embedded logic and render the correct UI. And this is a problem for some very good reasons. If you add business logic to a component, you've locked that component. It cannot be reused with different logic, which means you need to understand the logic to use the component or to change the component. And if you want to change the logic, you'll probably need to add more props. So by removing the business logic from our components, we're going to gain flexibility. We can understand and we can augment with much more ease. And we can also reuse that component with different logic. So since our ideal API removes the need for the embedded logic, we can pull it out into a separate function, like this. And we no longer need the 14 props, apocalypse avoided. Plus, we benefit from centralizing our logic, which is easier to reason about. And we can test our components separately from the logic. Now, I know sometimes it's nice to have just a drop-in component that just does it all. I mean, magic can be a lovely thing, sometimes. Something that just works can feel really wonderful. But I want you to think about the level of magic that you're aiming for. Do you want a rabbit in a hat, a trick we all kind of know how it works? The rabbit is in the hat, guys. Or do you want a vanishing elephant, like a trick you would have a harder time figuring out, what the hell's going on here? You don't want so much magic that an engineer can't figure out what's going on. The more magic, the less flexible the component is. Since the schedule CTA is vital to the site, I want very little magic. That's part of why I chose this API. I want to give the engineer who uses this some clarity about what's going on. Give the schedule CTA a type, get back a CTA. But I also wanted a simpler API because I'm aiming for engineers to use this component. I want them to be able to safely navigate it, and I want to not be kicking myself for code I won't be able to understand after a few months of not looking at it. Now, we actually get to decide what to do with the actual CTAs themselves. We've decided our API structure for the overall schedule CTA component, but now we have to deal with the individual CTAs. And we have two options here. So the first one is to use a base CTA component, and we're going to change out the messaging and props based on the type. The option 2 is to write each CTA type as a separate component. So there would be a reserve CTA or a cancel CTA. Now, if you're leaning towards option 1, you might be thinking that CTAs look similar, and you could get some reuse out of a base component. Less duplication of code, one place to update. That sounds pretty good. But each of these CTAs needs to be modified depending on the type. For example, the join CTA is a link, but the reserve CTA is a button. So are we heading down the apocalypse path again, trying to reuse one component for all of these? And if you're leaning towards option 2, you might be thinking that since the CTAs don't all share the same UI or same behavior, it makes sense to break them into separate components. You'll know where to make changes, and you can isolate behavior to a particular CTA. But you'll see some duplication of code, so you might need to update each component at some point, and that's definitely a pain. I actually don't think there's a right answer and a wrong answer here. It's just that we have some options with upsides and downsides. And ultimately, what I chose to do was to combine them into a third option. So I want a base component that handles some of the common UI, but I want to break out the CTAs into their own components so I can specify some behavior. So this is the base CTA component. I want it to be lightweight because its main job is to encapsulate the parts that might change more frequently, like the class name. And I also need it to not interfere with the differences between the CTAs. Like the fact that some of the CTAs are buttons and others are links via React Router and others are A tags. So I'm going to take advantage of ES6 defaults here, and I'm going to assign the button as the tag. But any specific CTAs that need a link or an A tag can override that. I like this because we get to encapsulate the most commonly used tag type, a button. And then when we override it, it's going to be very clear in that CTA that we're passing along that specific prop. I'm also going to be relying on the children prop to render the different CTA messages. Children is super useful when you have a generic container that's going to take more specific child components. So if you aren't familiar with this concept, this is a quick example using a bread component. So it is our generic container, and what we put in the bread could be different, right? Now, an alternative to the children prop, I could have just passed in like a message prop, right? That's valid. I could have passed in a string for each different message. But I find this less useful for this use case. One thing is that we use React International, and so for various messages, I'm probably passing in an actual component instead of a string. And when you're doing something like that, you're passing in a component via a prop, I'd urge you to consider using children. It's much more flexible and declarative. You can change the children components, the internals of the container, without needing to actually change the container itself. For our uses in the schedule CTA, we only need to know that whatever we wrap the base CTA around will be available as the children prop. So here I'm wrapping a formatted message component from React International to show the credits it costs to reserve a class. So we're taking a generic component, the base CTA, and giving it very specific children, as well as specific props, like the button primary class name. With this approach, I can also make sure that I have specific behavior. So the disable CTA doesn't do anything. When a user clicks on it, it just does nothing. It's just a grayed out state. And I can ensure in the disable CTA that even if someone accidentally passed down an on click to this, it will not get called. It's going to get overridden by this no op. And I can do other specific behaviors in my components. So when the join CTA needs like special analytics tracking, I can do that without touching anything else. And since the reserve CTA needs to open a modal, I can do that, and I don't need to worry about accidentally introducing a change to another CTA. And I can test each of these individual CTAs for the behavior specific to them, and changes to the CTA component are isolated to that component. We've also added some flexibility that wasn't there before. So we can now use the CTAs alone. This is the upcoming class page on ClassPass. So if you've reserved classes, you can go here to see all of your upcoming pages. And the only CTA it needs to show you is the cancel CTA, because you've already reserved these. But we couldn't actually do this previously. You'd have to use the schedule CTA and pass in the 14 props, because it was the thing that decided if you got that or not. And there is no easy way to not have to pass in the 14 props. But now that we've broken these out into individual ones, we can actually use them individually. So now this page just uses the cancel CTA, and it doesn't even bother with using the schedule CTA at all. It doesn't need to. So we've got our base CTA, which is used to create the individual CTA components. But we also have the schedule CTA, and it's not complete yet. We figured out the API for it, but we need to figure out how the schedule CTA knows to return like which CTA. Now, we could use a switch statement inside the schedule CTA to return the correct CTA. That's valid. But looking at our ideal API, I think I see a better option. So we give the schedule CTA a type, and it gives us back a CTA. And this reminds me a lot of requesting a key from an object. So let's use that pattern. We can create an object with keys and values that correspond to the types and their components. And now we'll use the type prop to grab the correct component to render. Now, if you're wondering why I'm assigning this to a component with a capital C, React allows you to dynamically render components, but the component needs to be capitalized. That allows React to tell the difference between a built-in component, like a div or a span, and a user-defined component, like our CTAs. And dynamic component names are just a nice method for cutting down on switch and if statements in your component. So here I'm using it to determine if I'm showing the left or the right sidebar. And here I'm using it to determine if I should wrap this content in a card. It's just a nice little trick I like to use a lot. And then this is actually the schedule CTA after our refactor. You'll notice it's much smaller. There's no scrolling. And I think it's pretty clear now. You can actually read through it and understand what's happening here. So it expects a type prop. And if that isn't provided, we're going to return null. And then we use the type to grab the correct component, and we assign it to the dynamic component name. And then we can pass our remaining props to that component. Now, our ideal API only had one prop, so where did these other props come from? Well, I kept saying ideal because it's going to change. We're going to need to provide some more props to it at some point. For example, we should probably add a class name so engineers can customize the styling. So you always start with the ideal API, and then as you start to build it out, you come to the more realistic API. And this is our realistic API. So we've gone from 14 props to 4. Most of the CTAs need some sort of schedule information. Like reserving a class, we're going to need to send like the schedule ID, and also for analytics reasons usually. And then we might also need a tooltip. But we've really cut down on what you actually need to send this component. But this is the realistic API, and it's really not far off from our ideal. So after this refactor, we can use whatever logic we want. We can use the individual CTAs alone. And we can add and remove the CTAs with ease. Because they're all in that object. If you want to add or remove one, it's as simple as actually just plucking it out or adding it to the object. And this was of great help for us for A/B tests. Now, I did this huge refactor, and the question was, like, was this actually worth it? Yes. This is everything that happened after I refactored this component. So I mentioned the A/B tests. It became much easier for us to add and remove them. We actually removed the disable CTA on some pages, so we had a little bit of a different logic problem there. The class names actually changed because we went through a rebranding. Messaging changed for the reserve CTA. And we had asked for like very specific CTAs on specific pages, specifically for like A/B tests and stuff like that. So we couldn't do any of this before, and now we could. Well, we could do the A/B test, but it was a pain. So refactoring was like absolutely worth the time it took for this. Making this more flexible really helped us down the road. Now, we finished the schedule CTA, but I want to keep going. I really want to work on a nicer option for this business logic that we pulled out during the first part of our refactor. So right now it's all in a function. So anytime you want to use it with the schedule CTA, you need to import it separately. And that's low magic, but kind of high annoyance. And I want the right level of magic. So to do this, I'm going to show you one of my favorite React patterns, the render props pattern, also known as children as a function. I spoke about the children prop earlier, and while that children prop can be child components, it can be honestly like anything. It can be an object, an array, a string, a number. It can be a function, hint, hint. If we make our children a function, we could do something like this. It might be confusing at first. Don't worry about it. I'm going to explain it, and then you're going to love it. So what's happening here is that this is a function that we pass as the children to the getScheduleCTA component. It expects a type, and it's going to pass that type into the ScheduleCTA. Inside of getScheduleCTA, that's where we're actually going to import the function with the embedded logic. I'm not passing in all the things that need to be passed into that right now, but it's happening, trust me. And it's going to give us the type. and then we're going to provide that type to this.props.children. So we're calling that function that we gave it, and we're passing in the type. And this is just a really nice way of encapsulating that logic for us so that I can just use the get schedule CTA component instead of having to use the schedule CTA and then go and grabbing the function that I want to use. Render props is a really powerful pattern because you can separate out the component that handles the logic from the actual rendering of the UI. So with render props, you delegate the rendering to the child function. It can return whatever UI it wants based on the information it receives from the parent. So again, for the schedule CTA, this is just a really nice option. So I'm showing you a really simple render props example and one that I use just to avoid having to import that separate function. But if you want to play around with render props, there's docs on reactjs.org, as well as I would recommend the Downshift library by Kent C. Dodds. It's an autocomplete library using render props. Render props isn't actually a new pattern. It's been around for a while. It just started to actually become very mainstream this year. We started hearing about it a lot more. So definitely play around with it. Understand what it's doing. It's a lot of fun to work with. But of course, I would like to caution that render props is just one tool in the toolbox. I'm very guilty of seeing a pattern like this and then wanting to apply it to everything. Which brings me to the part of the talk that I hadn't really expected to write. I thought this talk would be mostly technical, but in some cases, the why of building flexible UI isn't tied to the technical. It's actually about how you approach code as an engineer and how that impacts what you write. Okay, so I have this ongoing joke with a friend of mine. Bear with me, it's going to sound weird, but he loves lifting heavy things. He lifts heavy weights as one of his hobbies, but also he will literally lift anything heavy that he thinks he could possibly lift. It's a thing for him. And I joked with him one day that it would be really easy to catch him because all I have to do is put a big dumbbell on the sidewalk and he's not even going to think about why there's a dumbbell on the sidewalk. He's just going to go for it because that's his thing. And then you just throw a net over him, caught, right? And it started out as this joke between us, and then it grew to this thing that I would say to a lot of people, know your traps. It was what if placed on the sidewalk in front of you, would you instinctively go for and not even think twice, and someone could catch you with a net? And then the more I started doing this joke with people, I started to realize that this was actually a really important part of being an engineer. You need to know your traps. Do you, like me, see a pattern and then you just want to use it right away instead of waiting for the better use case? That's a trap. Or do you love one particular pattern and you just keep reusing it? Or maybe your issue is that you have a tendency to actually stay kind of stagnant and not learn new patterns at all. All of these are traps, and all of them are going to keep you from becoming a better engineer and from building better components. And then the other thing that I've thought about is, once you build those better components, are you willing to kill them? Because I actually come from a background of creative writing. I've been an engineer for 6+ years, but I actually have a background in creative writing. I even went to go get my MFA for a bit. And kill your darlings is a really popular saying in that community. If you've never heard it before, it means that if you've written something and some part of it isn't working, so you've written a story and there's a character that you particularly really like, but overall not working for the story, or a line in a poem that you think is really great, but actually it's detrimental to the whole piece of work, you need to kill it. As engineers, we're often very attached to the code that we write. I know I am. I mean, the schedule CTA is like my baby, but one day I might have to kill it. It might not work anymore. And when that day comes, I got to do it. So, kill your darlings. Now, quick summary of what we've looked at in this talk. We learned to start with that ideal API. We're going to let the API inform the component design. We're going to decide what level of magic we want. Business logic, we're going to remove that from our components. Render props is a cool pattern. Definitely use it. But remember to be flexible as an engineer. Know your traps and kill your darlings.